Hello guys, welcome back for another video on F5. Well, actually in the previous video, we have started off with creating a virtual lab for F5 in VMware Workstation environment. You can kick it off on any of the virtualization, like Oracle virtualization, KVM, wherever you want. You want to use Linux, Windows, or you have your own ESXi environment, you can do that. What we did last time is just a recap. We made two F5s in HA, and we created three networks on the VMware Workstation. That is out of band management switch and DMZ and the internal network. Today, what we are going to do is we have the LTM module enabled. So we are going to see how the F5 actually load balances the virtual servers and what do we have there for the load balancing, why it is the number one product out there in the enterprise market. So let's get started with that. Before I head to the configuration part, uh, you remember we deployed the two virtual F5s. If I remember correctly, this was complex password at 1.2, and here's my F5, virtual F5.1 and virtual F5.2. So one thing I'm going to talk about is you can see it's in awaiting initial sync. This is going to happen. You do whatever, but it will still keep on waiting for the initial sync. Even the time is correct, everything, but still it's going to keep awaiting for the initial sync. There is a bug on VMware Workstation that is going to make your life a little bit difficult while you're syncing to F5. So how we get rid of it is by turning off the TCP segmentation. This is the article from F5, the KB article. I'm going to mention it in the links down below. And this actually states uh, support for TCP segmentation offload and large receive offload. Since I'm a VMware virtual workstation environment, my card, probably network card, doesn't support this. While if you are in ESXi environment where you have a dedicated server running for the virtual machines, this will not happen. Uh, this used to be, these two parameters used to be off in previous versions of F5, like 11 and the backwards. But after version 11, this is enabled. So currently for our VMware Workstation Lab to work, we need to turn this off. So how we can do that? Let's get to our F5. So actually we can log in through our PuTTY session as well. That is a little bit handier than using the VMware Workstation. Let's try this one out. 172.15.1.10. This is my F5.1. Okay, so root. So you can see awaiting initial sync. So let me make it a little bigger. How can I do that? Let's change settings and appearance. I believe there is something here. I'm going to change. Yeah, it's a lot better. Uh, okay, so you can see here TMSH list. Yeah. Okay, we can actually copy this command and actually we can run it over here. So you can see the TMSH TCP segmentation offload value is enabled. What we are going to do is we are going to disable TCP segmentation and TCP large receive. I can show you both of them. They are both enabled. We are going to disable both of the values. See, it's enabled. What we are going to do, simple thing, we are going to modify and we are going to disable it. So modify value disable. See, the TCA, it has done, and we are going to modify the large receive and the value disable. And you can see both of the values should be disabled right now. Okay, here. And how could we can verify CMSH list disabled segmentation and large receive disabled. You can see both of them are disabled now. So let's head over to the other box, and that was 172.15.1.20 and root. Okay, let's make it a little bigger one more time. Pretty nice. Let's make it disable large receive. So we have done it disable and TCP segmentation. Okay, value is disabled. So we have it disabled on both of the nodes. Let's head back to our F5 GUI and we want to sync them. So, okay, we are going to online active one. So you go to devices, device management and overview. So awaiting for the initial sync. Let's push from the active one to the passive one, push the selected, and let's do it. Normally, I will tell you we keep the sync between devices manual. Why we keep it manual, I will let you know. Normally, what happens is you are working on the active node and you make some uh, configuration that you are not supposed to do. So if you keep automatic sync, what is going to happen? It is automatic going to sync over to the standby node, and you are going to be in trouble because you didn't wanted this behavior to happen. So what we do is we carefully make the changes on the active device, and then we manually sync it over to the standby. But the behavior can be changed. You can make it automatic by just changing a few settings in the device groups. So you can see it is in sync, but I got a message here that the time is not in sync. That's what I have told you guys, that the time has to be in sync. Otherwise, it will cause an issue. So yes, configuration, device, and NTP. You see here that I have provided 1.1. That is my actually my router IP, but it should not be the router IP. It should be the IP of my machine. That is my what do you call it? My Windows machine, which is running the NTP. Let's see what is my IP. IP config / all, and my IP is 101. So we are going to change it to 192.168.1.11. Update it. So you see, I have changed something on the second on the active node, and there is some changes pending. What you can do is you go here and push the changes. It will go. It will be sync. It's going to sync on the secondary node. So if I come here and try to see what happened. You see, I have changed the NTP on one of the nodes, and on the second node, it got synced, and I have uh, synced. So you see, it's 6 a.m. and 6 a.m. here as well. So this is how it works. So let's head to our configuration now. This was the bug that I wanted to explain it. because a lot of people are going to be in trouble and they're going to, it's not working for me, and they will be posting a lot of questions that on the VMware workstation it's not working for them. So this was the bug. Even I faced it, and I did a little research, and I found out about TCP segmentation and a large receive overheads. So let's head to our LTM part. Today, I'm going to show you how the LTM is going to work. So if you head over to this local traffic, you can actually see here virtual servers, policies, profiles. This is the part where the LTM configuration is supposed to be configured. So what we are going to do first? First thing first, we are going to add nodes. Nodes is nothing but the IPs. So what we are going to do is we are going to create three nodes here. Why I'm going to create three nodes? Because I have three Apache servers running that are web servers. I will show you. Let's head back to our diagram. We see our internal network is 172.2.0/24. I have three servers running here that is running Apache. I can show you over the VMware workstation. You can see my LAMP stack is running here. LAMP 1, LAMP 2, and LAMP 3. So you can actually download them from Bitnami LAMP. You can write it over the Google. It's actually free, open source, and you can download it. It's running on just small resources out there. It's not too much. They are taking a 512 MB RAM. So one processor, 512 MB RAM, and 50 GB of disk. I have configured them so to show the names of the servers on the pages. I will show you. Let's 1.110. This is my first server. No, it's not one. It's actually two. Okay. This is my first server. As you can see, LAMP01. And let's copy this and open up our second server, that is 120. You can see LAMP2. And let's open up our third server, that is 130. Let's head over to our F5s and start creating the nodes. So the first node is LAMP1, whatever name you want to give it, it's your choice. So if you have DNS running, so you can do fully quiet device name. But if you don't have in 2.110, just do this. You don't have to change anything. Just to repeat. 120 and repeat. And finish. So you have three nodes there that is representing an IP. A node is just an IP. So what you have is three nodes of LAMP servers that we have shown here. So what we are going to do is we are going to create a pool. That pool will have all these three servers in it. Let's see how we are going to create a pool. Let's create a pool and name it LAMP pool. Okay. The pool is where you are going to monitor your nodes. For example, if your LAMP server is down, like in our case, the LAMP 3 was down, how F5 is going to know that that server, the particular application is down? So what we define over the pool is called health monitors. Health monitor is going to see, F5 is going to do a polling. It can be ICMP, it can be HTTP, it can be anything what you define in the health monitors. So let's say I will do is a gateway ICMP. So, okay. And then what is my load balancing method? Is it going to be round robin? Round robin means one one after another and after another. So first request goes to VM node 1, then node 2 and node 3, and then again repeats node 1, node 2, node 3, like that. So if you can see, there are a lot of load balancing options in here. I'll not go into the detail of all of them, but I will tell you the most famous ones. Round robin, that is default one. Whenever you will create a pool, it's a default method of load balancing. There is a ratio when you have servers that are having not equal resources, where you want most requests goes to one server and then the other. So that time we use ratio member. And there is a least connection member, that is the most famous one. Normally I've seen a lot of people using that because they have in their in their server pool, they have same resources on all server. By same resources, what I mean is same CPU, RAM, means same compute resources. So what happens is they use least connection. So it's going to load balance and equalize the connections on all the nodes. It's whether it's 3, 4, 5, or whatever. So all servers will get equal number of connections. There are a lot of load balancing methods here. You can read about them. It's very simple, and in someone's scenario, probably one will suit or the other. It depends on how your setup is. Okay, I wouldn't mind round robin, or so let's see. So let's see what we are going to add the nodes in this particular pool. So node list, because I already have created. In case you have not created nodes, you can still create it under the pool. So it's going to be listed in the nodes, but you will create and they will be added here. Since I have already created, so I'm going to add them. So now, what is the difference between a node and a pool? Pool will have a service port, while node doesn't have a service port. So see, if I am going to put here port 80, so it's going to select port HTTP. It doesn't matter. You have port 80 or you can have any port on the web server. Your web server can run on port, any port you want. So you can actually change the port as per your preferences. But normally the web servers run either on port 80 or on port 443. So it's okay. You can select any port you want. So add lamp 2 on port 80, lamp 3 also on port 80. So we have 3 nodes already there. And what we are going to do is we are going to hit finish. Now you see immediately the pool came green because the ICMP is successful. That's what is happening. So it became green. So I will show you what are the health monitors. Here we go to local traffic manager, and you can see here monitors. If I click on the monitors, you can see here all the monitors. You can create your custom monitors. You can use the existing monitors. That is actually uh, depends upon your need. Normally, the best practice is for each of your application, you create a custom monitor. Uh, you create your own monitor, because if uh, you are version upgrading or there is some changes in this monitor, what will happen is one change will have a drastic effect on all of your applications. So that what you know don't want to happen. So word of advice, always create a custom monitor for your application. We are using a simple one, gateway ICMP. What it's doing is going to check the gateway ICMP. It's going to do the ping. So that's why you have your pool up immediately, because my network can reach there. So this is what. Now the last thing here is where I'm going to create a virtual server. Let's head back to our graphic. I have mentioned a DMZ network. So what virtual server is, basically it's a virtual IP where all of your clients are going to hit. They are not going to hit directly to your internal server farm, and F5 being F5 being the middle layer where it can have separate connections between the outside and the internal network farm. So it is actually at one time this ADC, application delivery controller, at the same time is managing both sides connections separately. That is why it has so many cool features, because it can see the client traffic coming and the server traffic. So it is maintaining two connections at one time. So that's why we have this virtual server that is actually a virtual IP, that where your client is going to hit, and based on that, F5 is going to make a decision which application behind in the internal network it is connected to. So let's go and define something with some virtual server. So let's create one, name it lamp vs on port 80. It's a standard virtual server. You have many types. You can go into the details again. So I'm creating a standard one. So who's going to access this virtual server? You can define a limit. If you leave it blank, it's understood it's 000/0 means anyone can access this virtual server. If you want, you can mention it here like this. What will be the destination? Destination is basically the IP what you are going to assign to this virtual server. That is again your DMZ IP or whatever it is. So in our case, we mentioned that it is going to be 1.0/24 network. So out of this network, we can give one IP, 1. Let's say 110. This is my IP of my virtual server, and it's working on port 80. So we give 80 HTTP. So let's keep TCP, and let's keep the defaults. Everything is a default. We are not going to change anything since we are not going to use anything out of here. We are not using SSL client or server-side profiles. One thing you are going to change in here, there is that source address translation. So we are going to use automap because its F5 is going to use its own virtual IP to connect to these nodes and can come back to itself with that same floating IP actually. That float IP we have mentioned in our VLANs. So F5 is going to use a floating IP to connect to these nodes and come back. So let's check other settings that we are going to use. No, I'm not using any HTML profile. I'm not using any iRules. And here I'm going to select a pool that is my LAMP pool. And I click finish. That's it. That is the configuration I did. And you can see immediately your virtual server came up. That is 1.110. So what we can do is we can ping 10, and you can see I can ping it, and it is replying to me. And we can actually go and open 192.168.1.110, and we hit enter. You can see it has opened my first server. Since we are using round robin, it has opened the first server. Let's refresh it. It's gone to the first server. It has gone to the second server. Refresh it one more time. It's working like this. 110. It is going to the second server. It is going to the third server. So it's like this. It will go to one request to one server, second request to the other server, third request to the other server. So the same way it is going to work out. So if we head back to our F5, and I'm going to see virtual address status, virtual address list, and then go to the statistics. So you can see I had maximum 3 connections and something like this. You are going to see the statistics. So this is how you are going to see it. If I head to pools and select the pool statistics, you are going to see the statistics in here as well. Currently there is no request. Maximum there was 5 requests that came in, and so on. So this was the most easiest and most uh, simple demonstration of how LTM actually is working. I think you guys will not have any doubts in that. Let's see, there are some changes pending since we have made some configuration change. On the first F5, there will be, because it was a standby node, there will be nothing in here. Okay. So let's look if there is anything here. No, there's nothing here. So what we are going to do, we are going to push the update and then again head back to the first node and see if we have our configuration there or not. The sync is done. Let's head back and do a refresh. Online in sync, voila, you can see all the lamp nodes in there. If you see the pool, you got your pool there. If you see the virtual server, you got your virtual server there. This is as easier as it is. You don't have to worry about anything. It will do it for you and you sync it. So you can see it's very simple. What makes F5 the number one device or the what you call it, the enterprise level load balancing solution? Because it can see the traffic that is coming in from the client side and what connection it is making to the server. So it is in between both the traffics. So it is a full proxy architecture. It is seeing all the connections coming inbound, outbound, going outbound. So that's why it is able to control all the traffic. I hope it is informative for you, and please don't forget to like and subscribe. Uh, I will bring another video. Next video will be on the ASM part. And if you do have any questions, please feel free to comment, and I'll try to answer them as soon as possible. I will do a video on F5 certifications as well, on the certification point of view. The next video will be on ASM part, and if you guys want me to explain few more things on the F5 side, we can do a video on that as well. Thank you, folks. I hope you have enjoyed the video.